Hello dear students, I am Pratima. I welcome you all to this video. So we are solving maximum minima word problem, application derivative. Today we are solving another important question of miscellaneous exercise, question number 18. So as I told, read the questions very carefully. Miscellaneous exercise 6, question number 18. It says, show that the height of a cylinder of greatest volume, which can be inscribed in a right circular cone of height small h and semi-vertical angle as alpha is 1/3 of the cone, and the greatest volume of the cylinder is your 4/27 pi h cube tan square alpha. So if we read the question and analyze, it is inside a cone there is a cylinder, it is inscribed, and what is given that height of the cone is given to h and semi-vertical angle is given alpha. What you have to prove? You have to prove that the height of the cylinder is, if I'll take as capital H, it will be h/3, and you have to show that if the volume of the cylinder is maximum, then it's is equal to 4/27 pi h cube tan square alpha. So if it is your height, small h, height of the cone, I can take the radius of the cone as r, and height of the cylinder, I'll take capital H, and this will be capital R, radius of the cylinder. So let us proceed. What is maximum? Maximum is the volume of the cylinder. What is given? Height of the cone is given, and the cone is fixed here, so H is constant. So let us draw the figure. So this is your figure. As I discussed, I have mentioned. So I have taken the radius of the cone as your small r, and radius of the cylinder is capital R. In the same way, height of the cylinder cone is small h because it is given. I can't change it. That's why I have taken the cylinder as capital H. So let me write as in the figure, your AB is equal to small h and BC is equal to small r. Then your BD is equal to height of your cylinder, I have written capital H, and DE is your radius of cylinder, I have taken capital R. Now volume of the cylinder, which is maximum here, this is pi r square into h. Because r I have taken the radius of cylinder, h I have taken height of cylinder, pi r square h. So this is maximum. So you know that we have discussed in earlier question, you have watched the video, you know that if anything is maximum, its derivative is 0. So when I'll find the derivative of v, so with respect to r or with respect to h, unless you change to one variable, you cannot do it. So to take help of other constant, I'll use the alpha, I'll use your h. So let us start one by one. First, I'm taking in triangle ABC. In triangle ABC, your tan alpha is equal to how much? BC upon your AB. Or directly you can write small r by small h. So this is one relation, h is constant, alpha is constant, so I can write r in terms of this. Second is I'm taking in triangle ADE. In ADE, your again tan alpha is equal to perpendicular by base, which is DE by AD. What is DE? It is capital R. And what is AD? You will see AD will be H minus your capital H. So H minus capital H. Now in the both the case tan alpha is same. So this will give you the relation between R and H. You can conversion formula. So R by H is equal to capital R by small r H into H. I hope you have followed up to this. So from this we will convert either R to capital H or H to R. So let us cross multiply. What I'll get H into R is equal to R into H minus H. Or how much is R? R is equal to, oh, sorry, this is very sorry, it will be small h, I think. This will be small h. Here also I'll rub small h. This is small h. RH tan alpha is small h. So R into small h is equal to R into H by this. So R small h will be divided. It will be your H minus H. And what is R by H? It is nothing but your tan alpha. You can write also, or you can keep it as R by H. No problem. Now, for volume, what is the formula? It is pi R square into H. So instead of R square, I'll put this. So let us write what will be R square. R square will be tan square alpha into H minus H whole square. So pi R square, I'm putting now R square here. So this will be pi tan square alpha into H square, I'm squaring, minus 2HH whole into H. So in V will be how much? It will be pi. Either you can write R square by H square, or you can write tan square alpha H square H multiplying plus H cube multiplying minus 2H square, and this is your maximum. Now I can differentiate it because here there is only one variable, which is H. So I'll make dV to dH as 0. So V is equal to pi tan square alpha, R square by H square is tan square alpha. We have written H square H plus H cube minus 2H square. Now what next? Differentiate it very carefully. So dV to dH, dV to d capital H. Pi is constant, tan square alpha is constant because alpha is given, and H derivative is 1, so it will become H square. This will be 3 capital H square. H square will be 2H minus 4H. H is 0 because volume is maximum, we have already mentioned. So this gives you pi cannot be 0, tan square alpha cannot be 0. So H square plus 3H square minus 4H is 0. Now you have to split the middle term. So it will become H square minus 3HH minus HH plus 3H square is 0. So this gives you H minus 3 capital H into H minus capital H is 0. So there are two possibilities. Either one is H is capital H but not possible. Both the height are not equal. So other one is H is equal to 3 times of capital H. This gives you capital H is H by 3. So first part is proved. H is equal to H by 3. Next, coming to volume. Volume of cylinder is equal to, here I'm writing in this expression, I'm putting the value of capital H as H by 3. So it was pi tan square alpha whole into h square into, in place of h, I'm putting your h by 3 plus what is be h cube? It will be h cube by 27. Next minus 2y is h, and h square will be h square by 9. So this will be pi tan square alpha, and I am taking h cube common. How much will be left? If you take h cube common, you can find out yourself. This will be 1 by 3 plus 1 by 27 minus 2 by 9. So V is equal to pi h cube tan square alpha whole into 27 is LCM, 9 plus 1 minus 6. Is it 4 by 27? Yes, 4 by 27 pi h cube tan square alpha. So other part is proved. Now verification. For verification, where to start? You have to start from your dv to dh. Where is dv to dh? This is dv to dh. So d square v to dh square is equal to pi tan square alpha. H is constant 0. So this will be 6h minus, this will be minus 4h. So in place of h, I'll put h by 3. So I'm getting pi tan square alpha. Small capital H equal to h by 3. So 2h minus 4h. Is it negative? Yes. So maximum verified. So I hope you have learned. So keep on watching, keep on subscribing, keep on sharing. We'll learn more questions in between. Have a good time.